Hello, this is Professor Kuehn, and welcome back to my Introduction to Astronomy at Wisconsin Lutheran College. We are starting into Chapter 14 in A Student's Guide Through the Great Physics Text, Volume 1. The chapter is titled Celestial Physics, and in this chapter we're going to be looking at the work of Johannes Kepler. Johannes Kepler was born in 1571 in the city of Wilderstadt, Germany. He received a Bachelor of Arts and a Master of Arts degree at the University of Tübingen. After completing almost 3 additional years of study in theology, he became a teacher of mathematics in Graz, Styria. In 1601, he was named the successor of Tycho Brahe, who was Kepler's mentor, and the imperial mathematician to the Holy Roman Emperor Rudolf II in Prague. Shortly thereafter, he discovered the elliptical orbit of Mars, which proved the experimental foundation for what came to be known as Kepler's first law of planetary motion. Kepler was very prolific, publishing works on astronomy, optics, and even the structure of the snowflake. His most influential work, the Epitome Astronomiae Copernicanae, was written in Latin and published between 1618 and 1621. That means Epitome of Copernican Astronomy in English, by the way. It was intended to serve as an astronomy textbook and hence organized, perhaps unsurprisingly, considering Kepler's extensive theological training, like a catechism, that is, in the form of simple questions and direct answers. In his Epitome of Copernican Astronomy, Kepler attempts no less than to provide an alternative to the Aristotelian physics which underpinned astronomical reasoning up until his day. Even Copernicus's worldview, though certainly novel, was still built on Aristotle's notion of perfect spheres executing uniform eternal rotation, a view which had been called into serious question by Tycho Brahe's recent comet observations and Kepler's own discovery of the elliptical orbit of Mars. The reading selection in the present chapter contains a dedication and some introductory material which precedes Part 1 of Book 4 of the Epitome. Kepler begins by explaining the motivation for his work and defending himself against the charge of novelty hunting, an apparently serious charge by his opponents which was intended to discredit his reputation. In doing so, he outlines how his Epitome addresses many of the very same questions which had been raised centuries earlier by Aristotle. That is the introduction and biographical notes on Kepler. Let me say a few things about them before we move on. First of all, I'd like to point out that Kepler was the student of Tycho Brahe. Brahe is a truly interesting character. He, like Kepler, was a Lutheran. They lived in northern Germany just after the time of the Reformation. Tycho Brahe was a very wealthy nobleman, and he had enough money, apparently, to buy an island off the coast of Denmark where he lived, and there he built one of the most fabulous and astronomically precise laboratories of astronomy that the world had seen up until that point. And then he dedicated his life, essentially, to studying the motion of the heavens. And Kepler, when Brahe died, inherited the work of Tycho Brahe. And so a lot of the work that Kepler did that we're reading about was based on his studies of Tycho Brahe's extensive observations of the heavens. Brahe, interestingly, he had lost his nose in a duel, so apparently he had a gold nose. So it sounds like astronomy isn't the only thing that he did. Let me see, what else did I want to say here? Kepler was training to be a Lutheran pastor for some time. He was studying theology, but then he decided to move into mathematics. Okay, so what does Kepler do? First of all, there's a section called To the Reader, and in this introductory section, what Kepler does is he explains the rationale behind publishing this work. The very first paragraph here on page 174 describes his intention. In particular, he says that in a larger work that he had written, he did a lot of mathematical calculations, and he realizes that this would be a put-off to many people. So it seemed, he says, to my friends that I should be doing right and fulfilling my responsibilities if I should write an epitome wherein a summary of both the physical and astronomical teaching concerning the heavens would be set forth in plain and simple speech and without the boredom of demonstrations. I did that before many years had passed. And so he's saying basically, if you find the mathematical demonstrations in my previous work difficult, here you go. Here's a more, a textbook version of what I am thinking about. You might see at the end of this paragraph, he says that you might doubt whether you were doing a part of physics or astronomy if you read this book, unless you recognize that speculative astronomy is one whole part of physics. What is he doing here? You might recall in our previous work, by reading the work of Claudius Ptolemy, his Almagest, Ptolemy had divided the study of theoretical philosophy into three branches: theology, physics, and mathematics. And you might remember that mathematics contained the subdiscipline of astronomy. Astronomy was seen to be the study of the unchanging orderliness of the heavens. Physics, on the other hand, according to Ptolemy, was a study of the changing, ever-changing nature of things here on Earth, that is, in the sublunary region. So there was a very strong distinction made between astronomy on the one hand, which applied to the heavens, and physics, which applied to the Earth. And what Kepler is doing here is he's saying that really there should be no distinction between the two. Whatever laws or principles govern here on Earth, physics, those principles also should be governing the motion of the heavens. And we're going to see that throughout the text. In particular, he tries to understand the motion of the heavens in terms of the kind of magnetic effects that have been recently studied by William Gilbert. So that's what he's saying here. If you get the sense when you're reading my works that you're not sure whether you're studying physics or astronomy, you're getting the right impression because they are governed by the same principles. Okay? In the next paragraph, what does Kepler do? This is at the bottom of page 174 and the top of page 175. He briefly explains the rationale behind the publication schedule of this work. He gives some details about how he had to break the work up into a few different sections in order to meet the dates that were set by the printers and the publishers of the work. I won't go into this in any detail, but it's of some historical interest. You might notice next, this is about in the middle of page 175, what Kepler does is he wants to give more details on what he's looking at in this textbook, in this epitome of Copernican astronomy. What he's doing is he is basically building on the work of Aristotle, and instead of reproducing all of the arguments, he simply includes a section of a letter that he wrote to a great prince, he says. So he's going to reproduce in the bottom of this page and the top of the next page sections of a letter he had written to a prince that would explain what he was doing in his epitome of Copernican astronomy. So he says here, accordingly, these are the excerpts from the aforesaid letter which have to do with the present undertaking. Now what does he do? He goes on to explain how what the kinds of questions he's asking and trying to answer in his work are the same kinds of questions that were asked by Aristotle back in his book On the Heavens, or De Caelo. You might remember having read selections of this earlier in the semester. So for example, Aristotle asks, for what reason are there many movements of the heavens? That is, why is it that certain planets, for example, experience progressions and retrogressions through the zodiac, and the moon does the same thing. It progresses through the zodiac, although it doesn't retrogress. The sun does the same thing. There are many different kinds of movements in the sky, and Aristotle is interested in answering these kinds of questions. So I, Kepler, ask, what are the reasons for the number of the planets? This is something that he's going to address. He claims to explain why there are precisely Mercury, Venus, Earth, Mars, Jupiter, and Saturn, 6 planets as opposed to 7 or 8. Aristotle, Kepler goes on to say, asks in the following chapter, for what reason are the heavens born from east to west rather than from west to east? You might remember that Aristotle saw, for instance, the sun rising in the east, setting in the west, as well as the stars and the planets. So why does it go that way instead of the other way? And so I, Kepler, ask, why is any planet move with so much speed, no more and no less? So Kepler is going to ask a similar question, but go a little bit deeper and ask, why do the planets move with the specific speeds that they do? In chapter 9, Aristotle asks, do the stars give forth sounds which are modulated harmonically? And answers no. You might remember this, again, from the work of Aristotle. He was interested in the question as the stars move around the Earth, are they emitting some sound that is audible to our ears? And what did Aristotle answer? He answered no. Then what does Kepler do? He says, I split up his judgment, for I grant that no sounds are given forth. So he agrees with Aristotle there. But, says Kepler, I affirm and demonstrate that the movements are modulated according to harmonic proportions. What does he mean by this? He's saying here essentially that although the motion of the planets and the stars and the sun and the moon don't emit any noise, that is audible to the ear, there is a certain harmony that is apparent to the mind when one considers it. In particular, if you look at the times of orbit, let's say of Mars and Jupiter, or of Jupiter and Saturn, there's a kind of ratio between those times of orbit that form these nice, clean ratios, kind of like the kind of ratios that are formed in musical harmonies. So when you hit a set of particular notes on a piano, you might form a major chord, or a minor chord, or an octave, or a fifth. So too, he says, if you consider the times of orbit of the various astronomical objects, they have these harmonies. In fact, Kepler wrote a book called The Harmonies of the Spheres, which tries to, write down the score, or the musical score, that corresponds to the motion of the planets. This idea of the music of the spheres is really permeating Kepler's work. And in the end, this, he suggests, points to a mind that is governing all of the motion of the planets, and the divine architect, that is God, who made it. This is something that comes through very strongly in a lot of Kepler's works. Okay. So then he says in chapter 10, Kepler asks about the order of the spheres, the intervals, the ratios of the movements of the orbital circles. That is, how the orbital spheres on which the planets are riding are arranged, how big they are, what's the spacing between them. But he merely asks, and he fails in his attempt to answer them. And then Kepler says, not only do I answer these questions with most luminous demonstrations by means of the 5 regular solids, we'll come back to that later, but also I add the number of the planets, which has been deduced from the archetype. So what he's going to claim is that while Aristotle broached these kinds of questions, not only is Kepler going to be able to answer them, but he's going to go farther, and he's going to present the archetype, or the model, or you might say the blueprint for the structure and the orderliness of the solar system. That is, he claims to have decoded, in a sense, the plan that God had when he built the solar system. You might agree or disagree with him, but that's what he's getting at here. A lot of his work is aimed at understanding the rationale, the orderliness of the solar system, and how that points to the existence and the nature of God. Okay? So let me see. I might skip over a few things here. But the main point in this paragraph, and the previous one, that is the paragraph on the top of page 176, is to show that what Kepler is doing is really building on the work of Aristotle. And he's trying to present himself not as a radical who's breaking with tradition, but rather one who's continuing this tradition that was started and I guess exemplified by Aristotle in his studies. Although Kepler says he is going to break with Aristotle on certain ideas. So for example, he is going to argue that the universe had a distinct beginning in time, whereas Aristotle believed that the universe was past infinite and future infinite. That is, it's eternal. Kepler says that's something where Aristotle was wrong, because Kepler, after all, is coming at it from a Christian perspective, and from a Christian perspective, the world had a beginning at a particular moment in time. So it had a beginning, and it's going to have an end. So he's going to differ with Aristotle on some points. But, and here's an important point, he says that although he's going to differ with Aristotle on some particulars, he's keeping up with the spirit of Aristotle. Namely, Aristotle encouraged his students to read widely. This is at the bottom of page 176. Aristotle in his Metaphysics says, he sends his students to the astronomers, and who defers to the astronomers in respect to their authority and the weight of their testimony. Okay, so in other words, he tells his students that they should read widely, read the works of even astronomers with whom they might disagree, and to follow, said Aristotle, not the most ancient opinions, but the most correct or the most accurate opinions. So Aristotle had an eye to his students studying a lot of different works and assessing them, and judging them not based on, you might say, authority or ancientness, but rather accepting them based on whether or not they're accurate. And so Kepler too is saying the same thing. He's saying that you should study a lot of different texts by a lot of different experts, but don't just accept the one that's the oldest out of tradition. Rather, look at which one is the most accurate. And so in this way, Kepler is saying, my spirit is like that of Aristotle, the spirit of inquiry and assessment of ideas. And so even though I might disagree with Aristotle on some particular points, Aristotle would approve of what I'm doing. Okay? Let's go on to the next page, page 177. Here he's talking about the work of the academies or of the schools. This, I think, is a very fascinating section because he's wrestling with the idea of what should be taught in schools. Remember, this is a letter written to a prince, and this prince presumably had some authority over what people were being taught in the academies in his principality. And he mentions here that schools at this time taught not necessarily the things that are most true, but the things that are easiest and most convenient for the teacher to teach the students. Now, you might ask yourself, do you think that's the case today? Do schools tend to teach the students not that which is most true, but that which is most convenient or easily digestible by the students? It was at the time of Kepler, according to Kepler, and I suspect you might have some opinions of this on your own. In any case, why is he bringing this up? Because remember, he's writing this letter to this prince who might have some say over what's being taught in the schools, and the prince might be saying, oh, if Kepler's coming up with these new ideas where the planets are moving in ellipses instead of circles, like what Copernicus had taught and like Ptolemy had taught, it's going to confuse the students. It's going to be very difficult and hard to convey. And so, am I now going to have to refine all these curricula and teach the students all these new things and have my instructors teach the students new things? And Kepler is saying, actually, no. You don't have to. You don't have to introduce my ideas all at once. Rather, I think what you should do is simply make them available for private study and for research by scholars, and then as they're found to be correct, one can introduce them at will. So don't feel like you have to suddenly change the curriculum at all the schools right now. I think that's what he's basically getting at right here on page 177. Okay, tell you what, why don't we take a break right there, and I'll come back and lecture a little bit more on this introduction next time.